So yesterday's was a whole bunch of stuff dealing with that dot product. Remember, dot product is like multiplication for vectors, and it results in a single number. We do first times first and second times second, but then we add those two together. So given u is 7, -3, and v is 2, 8, if I want to find the dot product, I would do 7 times 2 plus -3 times 8, and I'd get 14 minus 24, which is -10. That's the dot product of u and v. And again, it would either say find the words dot product, or it would do u dot v like that. Those mean the same thing, so be prepared for either. For 2, it says find the angle in between these two. So that's cosine of theta equals u dot v over the magnitude of u times the magnitude of v. I already have the dot product because I found it in the first question. I need to find the magnitude of u, which would be the square root of 7 squared plus -3 squared, square root of 49 plus 9, which is square root 58. So this goes over square root 58. And then the magnitude of v, which would be the square root of 2 squared plus 8 squared, square root of 4 plus 64, which is square root 68. But that's the cosine equals. So when I type this in the calculator, and you can do it all in one step, you're going to do cosine -1. It opens the parentheses for you. You're going to do -10, and be careful. This has to be the negative button, not the minus sign. Any leading negative has to be that way. Then you do divided by, open up your square root, and keep both 58 and 68 underneath the square root. Don't separate those out. If you separate them out, they have to have a parentheses around the front and the back, so just be really careful. So second cosine -10 divided by square root of 58 times 68 should give you 99.16 degrees. So if I were to graph these two vectors, it should be just past 90 degrees. It should be an obtuse angle, okay, which would be consistent with what we just found. Questions on that one? Yeah.
Parentheses aren't necessary for this?
If you keep them underneath the root. If you separate out those into two square roots, or like in the homework, there was one that like it was root 25, and so you made that 5. Now you got to put parentheses around it because you'd have to group your denominator.
Wait, so you have to put, I don't know if you just asked it, you have to put a parentheses.
He did just ask, yeah.
On front of the 10?
No, it opens it automatically on your calculator. You don't need to put another one because there's only one thing in the numerator. You only put like if you're thinking back to a lot of cosines, we put that there because there was more than one thing in the numerator and we needed to group it. There's only one number in that numerator, so it's fine. All right, number 3 says determine if u and v are orthogonal. So we already have the dot product. The rule on orthogonal is if the dot product's 0, so they are not. If it had said, are they parallel, then that's when I would look at their slopes, right? So the slope of this one, of u, would be -3/7, and the slope of v would be 8/2 or 4/1. So either way, they're not parallel, they're not orthogonal. This would be a neither scenario, okay? It's your one multiple choice question. Parallel, orthogonal, or neither.
Why is it not orthogonal again?
We'll say again?
Well, why is it not orthogonal?
Because then the dot product would be 0. Or if you look at their slopes, they would be opposite reciprocals. You're welcome. Question? Yeah.
Would they be opposite integer?
Opposite what?
Opposite integer.
If it was a whole number, like the only time it's like that is 1. But if it was like -2, then the other one would have to be +1/2.
So negative, so like the opposite
And the reciprocal.
and there's one.
Yep. All right, so 5 is completely different. There's like one little thing that overlaps. But we are going to learn how to graph complex numbers and then find the trig form of a complex number. So go back and forth between complex and trig. So complex, remember these are our i's, right? So involving i's. And then their trig form is we're gonna learn how to put it on what's called like a trig coordinate plane. It's very similar to x and y. It's not a big deal, okay? There's like 2 little formulas you gotta remember from this. That's it. So the first is, how do I take a point and plot it on my complex plane? It looks just like an XY coordinate grid, except that now the X would be the real, so the X is going to be the A part of my complex number. And the Y is the imaginary, so the Y is going to be the B part of my complex number. Remember, complex is A plus BI. A does not have the I on it, B does. So if my coordinate point is, my complex number is like 2 minus 3i, then I would go to the right 2, and then I would go down 3. And that would be that coordinate point. It is just a point, not a ray. So real axis is your x-axis. Imaginary axis is your y-axis. All right, to find the absolute value of a complex number, we square root a squared plus b squared. So hopefully that formula looks familiar because we use it for what? Magnitude, okay? So it's like finding the magnitude. The absolute value of a complex number uses the same formula as magnitude. So again, if I had 2 minus 3i, I would get the square root of 2 squared plus negative 3 squared, square root 4 plus 9, and this would be square root 13. So the absolute value would be square root 13. Which is just the distance between the origin and that point. So if you think about it, if I had mapped this, the distance between these looks just like the vector. The length of the vector is the magnitude. We use the same formula for that reason. Example 1 puts those two together. It says plot the point and then find the absolute value. So for A, negative 3, 6, I'm going to go left 3 and down 6. Nope, just kidding. Left 3 and up 6. 1, 2, 3, 4, 5, 6. That would be negative 3 plus 6i. That would be that point. And then the absolute value of z is the same as the magnitude of z. Actually, 1 bar would be the same. So it's the square root of negative 3 squared plus 6 squared, square root of 9 plus 36, which is the square root of 45. I got to see if that breaks down. This would be 5 and 9. Then that does have a 3 that would come out. So that would be 3 square root 5. It's pretty much the same thing, except these aren't vectors, right? So it's found the same way. It's technically not the same thing because they're not vectors, but it is the same process. All right, so B is 2, negative 4. I'm going to go to the right 2, and then I'm going to go down 4. That would be Z, 2, negative 4i. And then I'd get the square root of 2 squared plus negative 4 squared, square root of 4 plus 16, and square root of 20, which is 2 root 5. Easy stuff, right? Just one more thing to remember, that's all. All right, the trig form of complex numbers allows you to take a point that would be on an imaginary axis, and if I overlapped my unit circle on top of it, figure out what that point would be. So the trig form is given by r, well, you have to find two parts to it. Z equals r times the cosine of theta plus I times the sine of theta. I as an imaginary, not I as an ij. So we have to find those two parts. We have to find r, which is the absolute value or the magnitude. All that's the same thing because r represents the radius, right? So radius would come out from your center. Square root of a squared plus b squared gives me the r. And then you have to find theta. So we use the value of tangent to find the reference angle using tan of theta equals b over a. So I'm going to have my x, I'm going to have my y, I'm going to say tangent of theta equals the y over the x, and then inverse tangent. The difference is that these will be unit circle based. So when you get your trig function, it will say the tangent of theta equals, and it will either be root 3 over 3, 1, 0, 1, and those are the ones that are the tangents around your unit circle, okay? So you're going to figure out what angle it is based on that and also where the original angle would lie, because you're going to be able to find a reference angle. There could be more than one answer. We'll walk through the process. This says, again, write the complex. So it's already in complex number. I know it because it has the I. And I want to put it in trig form. So I'm going complex to trig form. I have to find R, which is the square root of A squared plus B squared. And then I have to find find theta. And I know the tangent of theta is B over A, or the change in Y over the change in X. It's the same thing. What is 3I? In coordinate point form, or what is the A of 3I? 0. The B is 3, right? So if I were to write that, it would be 0 plus 3I. The 0 is the real part, which is the A. The 3 is the non-real part, which is the B.
But isn't it IJ?
This is not that IJ. This is where it gets confusing. This is I as an imaginary number, not as in vector. Does that make sense?
So then it would. So then.
The I
So
goes
B
last.
always has
Oh,
the
the I always goes last.
Yeah.
B is always has the
Correct. I know, it's hard. The B always has the I.
So I'm gonna
Why would they do that? Just to mess with me.
wait, so like, would you know when they're talking about
Yeah,
IJ?
Yeah, because you're saying complex number in the directions. It will say complex number to trig form. As soon as you see complex, you're thinking imaginary. Complex means imaginary. The other one would say something like using the vector V, and it would be a V equals, and then you'd have your 3I plus 2J. I also went in order on your test, so hopefully that helps. Yeah. All right, so now I can find my R. My R is the square root of 0 squared plus 3 squared, which would be the square root of 9, goes back to 3. Then I get tan of theta equals the B is 3, the A is 0. What happens when I divide by 0? It's undefined, so I get the tangent of theta equals undefined. Well, guess what's not going to help you right now? Your calculator. Can you type in undefined and hit tan -1? Nope. How do I know where tangent's undefined?
squares. It's the bottom.
90 degrees and
It's up here. Good. You're both right. It's undefined at the top and it's undefined at the bottom. How do I know which one to pick? Because there's only one right answer.
The one that's the positive one?
because there's a positive imaginary number.
What if I had asked you to graph 3I? Where would it be? It would be right up here. 1, 2, 3.
Did you have negative 3I?
Sure.
So that'd be at the
So
bottom.
that'd
Yep.
be 120.
And then
So we pick the radians here. What's the radian at the top?
Oh.
Pi over 2. So theta is pi over 2.
Wait, how did you know it wasn't the bottom?
Because my coordinate point, like 0 plus 3I, would tell me I don't go right or left at all and I go up 3, right? My x-axis would be 0 and my y-axis would be positive 3. So the trig form is r comma theta. Is r times the cosine of theta plus I times the sine of theta. That's on the last slide. So it's 3 cosine pi over 2 plus I sine pi over 2.
this is the standard form.
Yep. Yeah, let's distribute that in. It would be just 3. It would be 3 cosine pi over 2 plus 3I sine pi over 2, like that. But you don't need to distribute in. You can leave it just like that.
How do you get like cosine and sine and pi over 2?
Theta is pi over 2. So I plug the pi over 2 in where theta is.
And then tan theta.
Tangent of theta was undefined. That's how we figured out theta. So the goal from this part is to find the actual angle. So if tangent of theta was undefined, then theta is pi over 2. And then we plug pi over 2 in place of the theta.
So you're looking for the radian.
So you're looking for the r and the theta in radians. Yes.
So we can just leave it like that? We don't-
Yeah, you leave it just like that. You can check this like with extra time, which I'm not sure you're going to have between the law of cosines and sines and all that stuff. But if you wanted to check this, you would like simplify this. So what is cosine at pi over 2? 0. What is sine at pi over 2? 1. Distribute this in and I'd get 0 plus 3i, which is 3i. So it's converting from one to the other, one form to the other. That's all.
Wait, so once we get the rating, that's what we're going to put for both cosine and sine?
Because theta's on both of them. It's sine of theta. You're replacing theta, and theta is pi over 2.
So once we get the tan, so once we find what the tan is and we find the radian based on the unit circle,
Correct.
that we're automatically plugging that in.
Correct. Yep. And they will all be unit circle based. So I'm probably going to give you like the little unit circle the day before, and so you can at least fill in, like I would say just fill in your tangents would probably be enough, but it give you enough to get a head start on the test. We'll talk about that like Tuesday. Like I'll talk about strategy on unit circle on Tuesday. All right, last one. So what I would say you would want to have is on your unit circle, you would want to have your angles, which obviously 1, 2, 3. This would be pi over 6, pi over 4, pi over 3, pi over 2, 0. You could keep going all the way around. We really just need the tangent. I mean, we really just need the radians, but I could go all the way around. Remember, it's 1 less in the second quadrant, 1 more in the third, and 1 less than double in the fourth, or 5, 7, 11. And then I would make sure to add on the tangent. So the tangent at 0 is 0. The tangent at pi over 2 is undefined. The tangent at the over 6 is root 3 over 3. At over 4 is 1, and at over 3 is is root 3. You could fill in all the way around. Like I'll give you a couple minutes the day before, so we're talking Wednesday. And you could fill it in all the way around if you wanted to. But hopefully you know enough to be able to even just know one quadrant and then move it, because you're going to have to move it around. And you'll see why in a second. So this one says, write the complex number in trig form. Again, I need r times the cosine of theta plus I times the sine of theta. R is the square root of a squared plus b squared. So it's the square root of negative 2 plus squared plus negative 2 squared. Square root of 4 plus 4, which is square root 8. And that reduces to 2 root 2. That's the r. Then I do tan of theta. Tan of theta is the b over the a. So tan of theta is negative 2 over negative 2, and tan of theta is 1. If tangent of theta is 1, what's my denominator on my radian? It's over 4, right? But is negative 2 in your first quadrant? No, it would be where? Good. So the over 4 in the third quadrant is 5 pi over 4. Yep.
So you wouldn't keep over 4?
It is, but you have to figure out what your numerator is. If they were both positive, if it was 2 plus 2i, now I'm in the first quadrant, I'd pick the pi over 4 in the first quadrant.
Wouldn't it be negative pi over 4?
No, we use the natural, well, that would be negative 3 pi over 4, but no. We use the natural angles. You're not restricting this. This is not an inverse function. So you're using your natural unit circle. So then I would get 2 root 2 times the cosine of 5 pi over 4 plus I times the sine of 5 pi over 4. Let me make sure the format on the website matches that. This is 7. So in 7, this is already in trig form. It's giving it to you in degrees, but that is in trig form, and it wants you to put it into standard form. So you literally just like figure out what that is. The cosine of 135 would be in your second quadrant. It's the over 4 there. So the coordinate point there is root 2 over 2 and root 2 over 2. And then you just plug that in. So it'd be 3 times the cosine, which would be root 2. Well, I can distribute first. Let me distribute so it's less confusing. Cosine 135 plus I sine 135. we would distribute. So it'd be 3 cosine 135 plus 3I sine 135. And then you know the cosine at 135, we just said is negative root 2 over 2. And then the sine there, 3I root 2 over 2. And then you would just push the I to the end. That's all really. So this becomes negative 3 root 2 over 2 plus 3 root 2 over 2I. So the I should be the last thing that you type in, and then that's the format of your answer. I think it's just taking the regular I, so you don't have to use like the I from the little, because this is not a vector. It shouldn't even give you the vector menu. So the other ones are the other way. So pay attention to what the directions say, right? Like if it's in it before, this says represent the complex number graphically so that it is complex, and then you want it in standard form. So you're going the other direction. Everybody good? Yeah.